I'm really glad to be here. I was here last year just as an observant, and now I actually get to present. So I'm glad to be in such a good company, actually. Because I'm just a PhD student in Charles University in Prague, and I am a part, like a semi part of Klára Hluchová's group. And oh, by the way, how do you turn the cursor into a laser pointer?
Yeah.
Can you see the pointer?
Yeah, it's a dot.
Cool. So our group is focusing mostly on, as I write in here, essentially reduction of amino acid alphabet. And what this means is that we try to make synthetic proteins and reduce the amino acid alphabet in organisms. And this is because we are looking at the evolution of proteins and amino acids. So we work with the origin of life and such. And here I depicted our group as a stickman. And on the top is Klára, who is the PI. There is her right hand, our postdoc Valerio. And there are like two main parts of research. So this one on your left is the protein people who are working mostly with reducing amino acid alphabet in proteins to see if they actually make any faults and such. And as you can see, this part is quite big compared to the other ones. And it's not what I'm doing, and I'm part of this group, a much smaller one, which is actually trying to reduce the amino acid alphabet in vivo, in living organisms. And then there is the bioinformatics people, membrane people who are kind of off, and our lovely lab technician. Yeah, so if we look at the amino acid alphabet, and here I depicted the amino acids based on very loose connections, so you might work those through and like print screen or something. We try to actually get rid of some of these to see if proteins or organisms can actually work in a meaningful way. And when you imagine the evolutionary timeline, on the beginning is like the beginning of our lovely planet Earth, and somewhere around here is the contemporary times. There are some amino acids that we know were on the beginning, or that can be made without the presence of living organisms, such as valine, because Valerio, valine, aspartate, alanine, glycine, and such. And so, you know, if you recall these meteorites, such as Murchison meteorite and others, or miliary experiments, you see that some of these amino acids actually are there. And there are some which we think, or we have suspicion that they cannot be made without the presence of living organisms, without enzymes, to say. There are some other ones like asparagine and cysteine, which we don't really know, but cysteine I think was found somewhere. So, but these like aromatics like tryptophan and tyrosine might be the ones that need organisms. And essentially, we try to reduce these, what we call light amino acids, to see whether the proteins and organisms can actually work without them. So moving on to Syn3 and our plans with it. Courtesy of David Goodsell and his lovely illustrations here. And we, in our lab, there are two people who are working with Syn3. That's me and Vitek, who is actually going to give a talk tomorrow, if I'm not mistaken. And our plans are that, again, here the stickman is that I'm going to be doing the laboratory evolution of Syn3, and Vitek is going to do gene editing. So I'm going to talk about this. And this is continuing of my previous project, which was working with E. coli. So I had auxotrophic E. coli, and I was doing just a normal laboratory evolution, essentially starvation experiments. So I had the cell, I put it in a liquid medium, M9 with chemamycin and some percentage of set amino acid. We worked with several ones with early and late amino acids, and you know, it wasn't that successful. It seems that E. coli has a lot of escape mechanisms to actually. So it seems that it can work it out, the starvation in many ways. But our hope is that Syn3 actually won't. So we hope to see some amino acid replacements in evolution, and therefore we might see if the amino acids are actually dispensable or not. Actually, this is a bit of a side note. Where today we were looking at growth curves, and actually it's really nice that we were provided M-cherry strain, because it seems that I will be working with this one, because you can make really nice growth curves by M-cherry signal in plate reader. So this is what I will be probably using. And onto the middle medium, I'm using the recipe provided by, again, JCVI. Some of you may know this. And I have problems with it. So far, I had success with growing the cells with KO serum. So the middle medium actually proved to work. But because we want to get rid of amino acids, or not get rid of, but we want to control the amount of amino acids, we need to control it. So problem is with lipid delivery, and this is, I think, is what my problem is. So there are two ways of delivering lipids to the cell. One is BSA, which is present in the serums, or you can add it separately. And this for me is a no-go, because there is tryptophan in it. There are actually 3 tryptophans, and some other ones, some other late amino acids, because there's a lot of like tryptophans, tyrosines, and such, which we essentially want to get rid of at some point. So we don't want to use this. So I want to use cyclodextrin to deliver it. And this is the lipid that I'm using. It's palmitic oleic acid, cholesterol, phosphatidylcholine, POP-C, and variations of sphingomyelins. I dissolve them in ethanol, and yeah, this is just for you who don't know that the several lipids complex with some different cyclodextrins. So POP-C and sphingomyelin complex with the smaller one, alpha cyclodextrin. I use methyl cyclodextrins, and these smaller ones, paradoxically, like palmitic acid and oleic acid and cholesterol, are complexing with the bigger one, the beta. So what I'm doing is that I always put it in a tube, an Eppendorf tube, with the solvent, ethanol in this case. I evaporate it in a speed vac for 3 hours or more in room temperature, and it's because our speed vac is ancient. And oh, sorry, just a minute. Oh, sorry, I'm here. And that's because our speed vac is ancient, and the settings for temperature are either low, which is room temperature, I suppose, medium, and high. So better use room temperature for that. So it evaporates, and then I put in the solution of cyclodextrin, and I'm mixing it and on the thermoblock overnight in 40 degrees centigrade, and then I cool it and use it and store it. Yeah, the concentrations and lipids to cyclodextrin ratios kindly provided by James Science Group. Hello. Anyway, when I'm preparing it, this complex. I thaw it, warm it up, and cool it, and then add it directly to the cultivation tube. There is some adaptation time because I presume that you cannot really put it in the medium without the serum from the get-go. So I always just reduce the amount of the KO serum in the medium. But so far I didn't have any success. Yeah, and there are several problems also, which I noticed, that my SP4 and the medium that I now talked about is quite pale compared to what we got from GCBI, kindly. Somehow it seems less concentrated, and I don't know why. I have some pictures that I will show you, and also I see no OD, even in the SP4 that GCBI gave us, which is quite interesting. Even though we see some clumping of the cells at the bottom. Yeah, there also is a problem with the lipids because I just struggle with them, and it's quite interesting that or not interesting, it's a problem for us that all those serums and BSA has amino acids in it, and we want to control it. So it's a problem for us. Also, one problem is that this component of the medium, CMRL 1066, which is this complex but defined medium, has also amino acids in it. I tried to ask the manufacturer to make it without those components, but the minimum order quantity is 10 kg, which is really a lot. So that's a no-go for us as well. But so we need to work with this somehow. And yeah, this is to see the comparison. So this is all of this is my medium, except for this, which is what GCUA gave us. And you see it's quite a lot more concentrated. And everywhere you see that the OD is non-present, and even on the plate reader it doesn't give any results. Yeah. So this slide I made after the presentation from Shigeyuki, and so I think that either I might use also the PVA, which I don't, and I had this thought because Shigeyuki said that that they didn't observe any growth with free amino acids, but I do, which is weird, you know. And I'm not really sure why, but it seems to me that I was thinking about it because the only it might be that the lipid diet might actually not be the problem, but the source of amino acids. So perhaps the reason is that they don't grow is that they don't put in the oligopeptides, and the reason it grows is that the cells actually might just cleave and eat the BSA. I don't know. It's just I just put it out there, and this also might be the reason for my low OD. Anyway, so this is it. It's not much, I know, but I hope I get some troubleshooting out of this, and I also thank you for listening, and I thank to my wonderful group, who is it's really a pleasure to work with them, and I really like them. By the way, this competition I won. Okay, so this is it from me, and I'm happy to take any questions and recommendations. Thank you.
Thank you very much. So, anyone want to start? I mean, I see from us lifelong mycoplasmologists, there are a lot of places I can see would be useful to go. James, go ahead.
Hey, Matej, just a couple of things. In our lab, the liquid CRML has given us problems when we tried to grow Mycoplasma genitalium.
Mm-hmm.
and certainly might be a problem with Syn3. We use the powder in the genitalium, and 3O grow in that fairly well. If the powder CRML is a problem, you could use replace it with isobutylix, which
Oh,
I
sorry,
don't
what?
believe has any amino acids in it.
Well, what? Sorry, what?
Isobutylix,
Uh-huh.
ISOVITALEX.
Oh, can you actually write it in the chat, please?
Yeah, I will.
Ah, thanks.
There's a couple other things. When I work with synthetic lipids, right, rather than serum.
Mm-hmm.
Okay. Now we were using BSA, of course, but we had to hot inject it into the media to get it to stay in suspension, not solution. Okay,
Mm-hmm.
even in BSA, right?
Huh.
So we would heat our ethanol up to 80 degrees and then literally force it into a liter of media at 80 degrees Celsius, right?
Wow.
And it would only stay in suspension for about 2 weeks. After that, the media wouldn't grow anything. The lipids would just settle right out of it.
James, are you using cyclodextran with this?
No, I am not.
Okay,
No, I'm
that
not.
might help.
I've tried that technique. This is just from, and like I said, we're one of the mycoplasma labs in the South. We try to isolate new mycoplasmas all the time, right? And the mycoplasma lab part of our lab has had trouble with the liquid CRML too. So keep that in mind.
Yeah, we use liquid, and I think that might actually be also the reason for the paleness, because I'm not actually sure why, but I'll actually keep that in mind and try to use the powder next time.
These bugs are extremely sensitive. I mean, extremely sensitive. Even lots of serum will change how they grow and how they work. Right? I mean, drastically change it.
Yeah.
Matej, we've always used liquid CMRL.
Okay.
And have never had an issue with that.
Mm-hmm.
It seems like for your purposes, Shigeyuke's synthetic media seems to be ideal for what you want to do.
Yes. I actually found that talk really enlightening.
Because CMRL, you'd have to formulate that. You'd have to get that made without the amino acids. But I look at it that Shigeyuke needs to become, you need to become best friends with him.
Yes.
And this should be doable. If you need to, I mean, you are welcome to come to my lab in California, but I know that in Germany, Leah Kloss works with our cells.
Yes, we're in contact actually.
And James Sayens works with the cells. There are groups in the Netherlands. There's certainly groups in France who have been doing this forever. Probably since, well, I not forever, but as long as I've been a mycoplasmologist, there have been groups in Bordeaux that are really good at this. So if rather than struggle with this, it might make sense to go and apprentice yourself to one of those groups for a little bit.
Yes, actually was in Dresden with James Science, and actually they taught me the lipids to how to do the lipids. So I might pay them a visit again to try the medium again, or Cologne with Leah.
And then, but what Shigeyuke showed us today will probably help you a lot in figuring out what you need to do, and whether the amino acids that you want to reduce your concentration of are so you might need to put some of them. You might need to make peptides.
Yeah, I think it really gets down to it. But that's a question, because when we need to make the peptides and we want to get rid of some amino acids, you said, or Shigeuke said that it seems that only cysteine is able to freely enter the cells. So we might want to think about whether we really need to introduce the amino acids in a peptide gradually lowering the amount. So
I don't think Shigeoki knows. I think some amino acids can probably beyond cysteine can probably enter the cells. Shige doesn't know exactly which ones have to be in peptides.
Yeah.
But you could still, even with the peptides, you could lower the concentrations of some amino acids by using a variety of peptides.
Yeah, sure.
Hey, John, I will chip in. This is Kim here. In the JC Guide version of the defined medium, it really used only free amino acids, not any dimers or trimeric forms. And we got down to a point where all the things were defined. Well, actually, if you use knockout, it does have a few amino acids, but again, those are free. So I don't know about the requirement for tri and dipeptides, but I think
but we had albumin.
Yes, of course. Yeah, Albumax is an albumin component of knockout, and it does have mostly lipids associated with it. Yeah, so I'm just saying that you don't. These transporters, we don't really know. I mean, they must be able to accommodate single or multimeric peptide compounds. But I just sympathize with your problems. You've got to kind of figure out how to get those down to a minimum. I don't really have a solution beyond the fact that you can grow them on free amino acids, I think.
Yeah, I actually would I find it interesting that Shigeoki observes no growth with the free amino acids, and I do, which because I think that the only source of peptides is the albumin.
Yeah, I think that's probably good enough though, because there are proteases on the surface of the cell.
Yeah.
Maybe,
So it might be actually kind of funny that the albumin is actually providing the amino acids as well as the lipids. It's kind of interesting.
Yeah.
And Shige's probably gone to bed because it's really late in Japan. But reach out to him.
Yeah.
He's a good guy.
Yeah.
I'm Syn3 here, John.
Oh, there he is.
Yeah. Actually, we removed all the protein, for example, albumin, BSA, yeast extract, peptone, and tryptone, and added the several synthetic peptide. And then we tested the growth, and so we are not sure why Syn3 require the polymerized peptide form, but and also I'm happy to share our recipe to you, and then please email to me.
Yeah, I sure will.
That's it. Thank you. Also, the PVA is polyvinyl alcohol is really effective to promote the growth of Syn3 without KO serum or FBS.
Yeah, I will sure try that one.
Yeah.
Thank you.
Thank you.